Hi Algebra 1, this is the video for fourth quarter, week number 2 assignment. Just a reminder that the questions I'm about to be going over are not the same questions that you need to answer on your own and submit for this week. The questions on your assignment that you are doing are different than these. So if you find yourself sitting there and copying everything down that I'm writing down, you are doing it wrong. You need to use this video to re-teach yourself how to do these types of problems and then use those processes to solve similar questions on your own. Number 1, factor completely. Whenever we are told to factor, the very first thing we have to do all the time is find a GCF. I look at these two terms. I've got 5x squared and I've got 25. The biggest number that goes into both 5 and 25 is just a 5. There is no variable in my GCF because 25 doesn't have any variables next to it. So the GCF is just a plain 5. When I have a GCF, I put that in front of parentheses, and then I divide and put my answer from the division inside. So 5x squared divided by 5, my 5 divided by 5 is just a 1, so that's 1x squared, or simply x squared. And then negative 25 divided by 5, well, negative 25 divided by 5 is negative 5. Now that's actually the answer to our question. I know a lot of you might be looking at this thinking that it stops because we've got x squared, which is a perfect square, and then we've got the minus sign. However, this is actually not DOPS because 5 is not a perfect square. So when you have something with two terms that's not DOPS, you can't do anything else to it. Therefore, this is our answer. Number 2, factor completely. Again, I want to see if there's a GCF here. There actually is no GCF in this question, which then I look at this and I'm thinking, okay, well, there's two terms, and what I just said is if you've got two terms, you want to see if it's DOPS. Now, to tell if something's DOPS, you want to make sure it has perfect squares for your coefficients and even numbers for your exponents. So a to the 6th, my exponent is a 6. Since 6 is an even number, that makes this a perfect square. PS stands for perfect square. A to the 6th is a perfect square. B squared, well, my exponent is a 2. Therefore, B squared is also a perfect square. So both of my variables are perfect squares because they have even exponents. Now I need to check my coefficients. So 49, well, 49 is also a perfect square because that's 7 times 7. And the imaginary coefficient at the beginning of this question is just a 1, which is a perfect square because it's 1 times 1. We don't need that in this question. Some of you are able to do this super fast, but I'm going to take it the long way just for those that don't remember how to do this. We break it down. So a to the 6th, well, that's a to the 3rd times a to the 3rd. Then we have our minus sign, so that's where I split this up. 49, we already said, is 7 times 7. And then finally I have b squared, and that is b times b. You always go in a row. So a to the 6th came first, so that's what I put first. Then the minus sign, so that's where I drew the line. Then 49, and then b squared. So I go in order. Then I make my groups. So I have two groups, and remember on the line, whenever it stops, difference of perfect squares, one of your groups gets a plus and the other one gets a minus. So this factors to a to the 3rd plus 7b and a to the 3rd minus 7b. And that is your answer. Number 3, factor completely again. So same deal, let's find a GCF. I look at this and I'm like, hey, maybe I could divide by 2, but then 11 can't be divided by 2. So there's actually not a GCF in this question, which means we're going to have to do this the long way using the AC method. So A times C, my A value is a 2, my B value is a negative 11, and my C value is a 12. So A times C, that's 2 times 12, which equals 24. So that's where our T-chart comes in. I need the number to multiply to 24, and I need it to add to your B value, which again, my B value is the negative 11. So this needs to add to negative 11. So basically I go through and I list all of the numbers that multiply to 24. So that's 1 and 24, 2 and 12, 3 and 8, 4 and 6. If you forgot how to find your factors, you can go to your calculator. So I have my calculator app here. You go to y equals, and you type in your number divided by x. So I want the numbers that multiply to 24, so I do 24 divided by x. And second graph, and this is where it lists all of your factors. You're looking at the whole numbers only, so you're going to skip 5, 4.8 because that's a decimal. But you see 124, 212, 38, 46, and then it goes backwards, 64, 83. You don't have to write those down because it's the same thing backwards. So now I go through and add these. Well, 1 plus 24, that's 25. 2 plus 12, that's 14. 3 plus 8, that's 11, but I need this to be negative 11. So the only way to multiply to a positive but add to a negative is if these are both negative, because a negative times a negative is also a positive. So negative 3 and negative 8 gives me negative 11. So these are the two pairs I'm going to use. This is not a shortcut problem because 2 is the coefficient on the x squared term. If there was no 2 there, then I could do the shortcut by just putting my two factors in parentheses. But I do have to do this a long way, which we split the middle term. So my negative 11x becomes negative 3x minus 8x. Or you could flip it around. You could do negative 8x minus 3x. Bring down the plus 12. Bring down the 2x squared. And then we factor by grouping. GCF of my first group. There's no number in common between 2 and 3 other than a 1, which I'm not going to use. But they do both have an x in common. So I'm going to divide this first group by x. So I put my GCF out front, and then I put what I get after I divide inside. 2x squared divided by x is 2x, and negative 3x divided by x is negative 3. Then for my second group, I have a GCF that is negative because my first term in the group is negative. And the biggest number that goes into 8 and 12 is a 4. So I'm going to divide these by 4, well, negative 4. And after I divide by negative 4, I get 2x minus 3. So since these match, I know I've done this correctly. I pull the 2x minus 3 out. And then I take what was left over, and that is my other factor. And that's our answer. So 2x minus 3 times x minus 4. Number 4. Solve the inequality below to determine and state the smallest possible value for x in the solution set. So, of course, I am going to start by distributing. 3 times x is 3x. 3 times 3 is 9. Is less than 5x minus 3. Now I want to get the x's on the same side. I have a 3x on the left and a 5x on the right. I am going to subtract 3x because that's the opposite of a positive 3x. I get 9 is less than 2x minus 3. Now we want to move this minus 3 to the other side because I'm trying to get the x alone. So the opposite of minus 3 is plus 3. And I get 12 is less than 2x. Finally, I'm going to divide by 2. So I get 6 is less than x. I do not like when it is written this way. I always want to make sure that my x is on the left of an inequality. So if we switch the x and the 6, we also have to switch the inequality. So this is x is greater than 6. Now, that's not the answer to our question. The question is asking the smallest possible value for x. So if I'm telling you x is greater than 6, that means all of the answers have to be bigger than 6. So if I drew a quick number line, we put 6 on there, 7 and 8, and then 5. All of your answers are greater than 6. So they're all of these numbers over here. But it's not greater than or equal to 6. So 6 can't be the answer. So the smallest integer that is greater than 6 is 7. So 7 is the answer to this question, because that is the smallest possible value for x in the solution set. This should say integer. It should say smallest possible integer value for x. Integer just means a whole number. Number 5. When multiplying polynomials for an assignment, Pat found the product to be negative 4x plus 8x squared minus 2x to the third plus 5. He then had to state the leading coefficient of this polynomial. Pat wrote down negative 4. Explain why Pat's answer is incorrect. We did this in a past video talking about leading coefficient, and we learned that the leading coefficient is the variable attached to the highest exponent. So he's incorrect because negative 4 is not the variable attached to the highest exponent. Because the leading coefficient is the variable attached to the highest exponent. Oh my gosh, sorry, I wrote that wrong, and I'm not starting this video over. It is the coefficient attached to the highest exponent. That's the number. It is the number attached to the highest exponent. So to figure out what the leading coefficient is, we have to put this in order from highest exponent to lowest exponent. So first up, I have a negative 2x to the third. Then I have the x squared, that's my next highest exponent, so plus 8x squared. Then I have the x term, so minus 4x. And then finally, I have the term without any exponent at all. There's no variable, so plus 5. So the actual leading coefficient is the coefficient. It's the number attached to the term with the highest exponent. My highest exponent term is the 3, so the number attached to that is negative 2. This is another reminder. The answers to the questions that you are answering are not the same as these because the questions are not the same as these. So please use what you learned in this video